Hello everybody, my name is Rafael and today I want to show you why it is important to make wind forecasts, in particular for range prediction systems and for trip planning. So, when we go at higher speeds, air resistance becomes basically the major component of the energy that you need to put into the car to drive fast. But there are actually two components to it. One is you driving your car, so your own velocity, but the other one is wind. So I want to demonstrate that on a short example. So why is wind important? Consider just yesterday you drove here from Berlin to Stuttgart, and you did that with your electric vehicle, and your vehicle planned a charging stop for you. But what actually happens if you have strong headwinds along your route? What can actually happen is that you're missing your planned charging stop and you have an unplanned charging stop before because your battery is empty. Well, and a pretty similar question we did in a pilot project with Mercedes, because the Mercedes-Benz Vision EQX6 team asked us, well, we have that long trip and we really want to make it. Can you tell us about the wind? Does it really matter? And we did an historical analysis and over the last 30 years. And what came out is, well, in the best case, they have tailwinds, and that results in the order of 2% less energy they need. And in the worst case, they need 6% more energy. But consider, as you can see actually, the EQX6 is a very low-profile car, so the wind resistance is very little. And what really matters for all of us is a real-world example, a typical battery electric vehicle. And well, we went out in another pilot project with Manfred, made some test drives, and we found out on one day we had a trip where we used 25% more energy because of the wind, which is 5.5 kilowatt hours per 100 kilometers. And that's huge, that's huge. But on the same day, we also had a nice tailwinds on the order of 1.5, which resulted in 1.5 kilowatt hours per 100 kilometers. So that is something you really need to consider. But the thing is, wind forecasting, in particular at vehicle height, is a really, really tricky business. So my question to you is, what do you see on the left side? And I think nobody has a clue. Well, it's the Vision EQX6, but it's a really bad resolved picture of it. And the question again, what do you see on the left side? No one? Okay, it's a valley in the Alps, and on the left side is a typical weather forecasting model. So it's the terrain at a resolution of 10 times 10 kilometers. On the right side is the resolution we use in our model, which is 30 meters. And the question to you is, which model would you trust? So we invented a model to make wind forecasts, and we put that into a product which we call Wind on Roads to provide these data, these forecasts to our end customers. And here's just an overview of the things you really need to take into account. On the top left is again the topography thing. So we have steep valleys, we have topography. The wind, the topography guides the wind, also changes the magnitude of the wind. And you can see the road in there. So you really want to know this. Also, we have a lot of vegetation around highways and Autobahn, and that these really matter. And for example, just to give you a number, in Germany, 33% of German Autobahns is close to forests. So it really matters. And you all know these things, these what we call roadside obstacles. These are basically everywhere, and you need to know where these things are to get a good forecast of your wind. And of course, there are other people on the road. These cars create turbulence that changes the wind, and that also needs to be taken into account. And well, so yeah, that's it. And I think there's just one question you have to ask yourself: how do I get wind on roads? And the answer is just behind you, next to the Vision EQXX. And please come talk to us. If you're an operator, if you're a car manufacturer or truck manufacturer, feel free to reach out to us. Thank you.